Welcome to qnawire.
Alright, we're doing problem number 4 of chapter 9 in Chemistry Essential Science. So the molecule drawn here is diffluoromethane. It's used as a refrigerant called R32. Based on the structure, how many electron domains surround the C atom in this molecule? So we have 4 bonds, 1, 2, 3, 4. So that means 4 electron domains are surrounding our molecule. So now, part B, would this molecule have a non-zero dipole moment? And yes, this is going to be a polar molecule. And they give us a few choices about us. And for part C, they say if the molecule is polar, which the following describes the direction of the overall dipole moment of the vector molecule. So we have to do that based on electronegativity. So the electronegativity of H is approximately the same as the electronegativity of carbon. So fluorine is going to these are both less than the electronegativity of fluorine. So the choices they give us, the overall dipole moment vector is going to be answer number 1. From the carbon atom towards the fluorine atom. Because the dipole moment is always directed from your non-electronegative atom towards your more electronegative atom. So for 2, the carbon, it's not going to point midway between the 2 fluorine atoms. That only works if both of your that would only work assuming both of your atoms have the same electronegativity, and at that point you would not have a dipole on that bond. And that the same follows through for question number 4. You could make an argument that the carbon is pulling on the hydrogen to the same extent the hydrogen is pulling on the carbon, but it's not going to create an overall dipole moment. And for answer C, from the carbon atom, the last explanation was for part 3, not for answer 3, not answer 4. So for answer 3 and answer 4, that you can make that argument maybe if the dipole moment is equivalent for both atoms, but even then you would not have an overall dipole moment for that bond. So 2 and 3 are wrong. For 4, since your electronegativity for your carbon is roughly the same for your hydrogen, you're not really going to have a dipole moment for your CH bond, but you will have that for your CH4, for your CF bond, which is why the answer 1 is